So if you are looking at this assignment in the module, you probably weren't here the day that we collected our data for this lab. This is the first lab of the second quarter. This is part of our changes in the atom section of chemistry. One of the things we need to really have our head wrapped around before we can get into radioactive reactions, nuclear reactions, where the identities of elements actually change. It's the only time that atoms change from one element to another. We have to understand the ins and outs of isotopes. So one of the main aspects of that is understanding how the weighted average is calculated. We did a bunch of work last unit, in Unit 4A, calculating average masses for elements based on numbers of protons, neutrons, and electrons. But I still saw some struggling with this concept as we went through the quiz. So to kind of drive this concept home and make sure that we really understand how the average mass is calculated and just how isotopes affect the mass of our elements, we are going to do a little activity where we're going to use 3 different sized paper clips to represent 3 different isotopes of the Paperclipium element. So we've got smallium, medium, and largium. And the data that you have provided for you down in our table here is you are given, in this section here, these are the masses of 10 clips. Okay? The masses that are given to you here are the masses of 10 small, 10 medium, and 10 large paper clips all together. That's a collective mass of 10 of these, 10 of these, and 10 of these. Okay? Now, to find the average mass, you're going to take the mass of 10, and then you're just going to do an average. So take the total mass divided by the number of clips. The total mass divided by the number of clips will give you this answer here. Okay? Now, those will be the masses of your isotope. So that'll be your isotope mass. That you're going to end up using to find your weighted average. The calculation is on the back. The calculation for the weighted average will be done on the back. There's a space provided for that, but you do need to write the answer here when you're done. Okay? Now, the next piece is that you're given the number of small, medium, and large clips that were put into a sample. We just built a random sample of at least 20 clips, and those 20 clips make up our just paperclip sample that we would find in nature if this was an element. The numbers are provided for you on the sheet in the assignment. It gives you the total number of clips. You're going to need to add those up to get your total. And then the mass of the mixture, the mass that's given here, is taking all of these clips, the number of each of these clips, putting them into a sample and getting the mass. So the total number of paper clips was put on a balance, and the mass of that mixture was recorded here for you. In this space right here, I would like you to do a simple average mass calculation, which is the mass of your mixture divided by the number of items in your mixture. Write out your equation for that, plug in your numbers, and then give your answer. Over here, you need to determine your percent abundance for each size paperclip, your percent abundance based on these numbers over here. Okay? So these percentages are going to be based on that over there. And remember, a percent is simply the part over the whole. Percent is equal to the part over the whole. That'll give you your percent. Then you'll have your percent and your isotope mass, percentages and your isotope masses, and you can plug those in over here when you do your weighted average calculation for the mass. That's what we did last week in our assessment. That's what we did last week in the subatomic heavyweight activity, and there were a couple other practice problems that we did on the back of that one worksheet. And then you have a couple more questions to answer. On the back here you can see. You should submit this through Cami. If you look at the assignment itself, the video will be up in here that you're watching now, but you should be able to just use your school-provided laptop and either write in your numbers using your stylus or type in your answers into the spots. Please don't forget to show your work here. Don't forget to show your work here. Equation, numbers plugged in, and answer. And then don't forget to show your answer for the average mass. The calculation is right here on the back. Okay, so show your work here, show your answer here for your average mass. If you have any questions, you can shoot me an email. This will be due by the end of the day on Monday, October 23rd.